the Chinese seems to have these obsession with toadstools. So apart from this common type, I also found this one online, and it comes in quite a modest box, and it's very clear that it's not intended for the British market at all. It's got basic technical data in English here, but only the actual numbers and measurements. But other than that, everything else in it is in Chinese. And this is a illuminated toadstool with a light sensor in the bottom. It comes in a somewhat better condition than this because I have already had it open because it was quite hard to get open in the first place. But it goes into this death adapter, and if I turn the lights out now, it lights up, and let's see, it does get brighter, I think, the more light you put out. I think it's quite sensitive. No, maybe not. But anyway, it lights up this hideous yellow colour. Not a nice colour. Although it is actually, if you bayonet cap this off, it is a warm white LED inside. So let's get the lights back on again. So I'll unplug that. Put that over there. It definitely does, it just bayonet caps in, it's quite nice that. It's a shame they put the warm white LED into this lurid yellow top. It would have been nicer if it had been a white one. But that's reasonable enough. Now let's see, have I got a notepad knocking about? There we go. So let's get the notepad and open this up. I've not reverse engineered this yet. I have opened it because I just wanted to see how its construction was inside. It was glued quite forcibly together, sadly. Oh, and seems to have just stuck itself together again. The LED is held in place just by a bit of foam at the top, and the wire, it just seems to poke in there. It's not really locked in place in particular. It's a 4.8mm straw hat LED, and it's got a very large chip in the end. It's a very big one. The circuit board here, I wonder if there's a charge in that capacitor. I shall just poke it to find out. Nope. I don't see the electrolytic capacitor. I see the usual capacitive dropper. Now this might be the one that just shorts out the LED. And there's a wee bit of foam here that I think is just insulation from the pins. Previous ones like this one, the light sensor on the bottom just triggers a transistor that shorts out the power supply, so that it actually draws a tiny bit more power when it's off. We'll see what this one this one's got. So okay, so here's the mains coming in. One leg goes straight to the bridge rectifier. The capacitor is 220 nanofarad, so 240 volt. So comes the capacitor, and then there's a resistor, and then there's another resistor in series. Okay, right here. So 220 nano with a tiny 8th watt 1 megohm resistor, brown, black, green. 1 megohm. Normally this would just go straight into a bridge rectifier, but it appears to have another resistor in series with it. Orange, black, brown. 3... Oh, okay, 300 ohm. Bridge rectifier, which is just a little dill bridge rectifier here. Through hole as well, which is unusual. And the neutral is going there. So that's me ruled out all this circuitry at the bottom. The neutral is going straight in. So let's bring out our rails here. The output of the bridge rectifier is going... There's no output smoothing capacitor, which is different from previous ones. The positive connection goes to the transistor. The negative connection goes to the LED. LED, there's a little diode there. Is that a Zener? The diode is across the... Okay, that diode is probably a Zener diode. Looks like it. I don't know what voltage that is. But it looks like a Zener diode to clamp the supply down to a fixed voltage to stop it going above the rating of the components, probably. Brown, red, orange, that's 12K. Brown, brown, I think that's brown, brown, yellow. So that's 110K. The transistor is connected to the LED's positive. So is that a PNP transistor? It must be if it's going up to the positive rail. So yeah, that's going to there. Then it's going to, okay, so the transistor is probably a PNP transistor. And it's connected directly in series with the LED. So that's probably PNP. The base of the transistor has that 12K resistor on it, which I guess is just going to a bridge of the light sensor and another resistor, which would be, it is. So the light sensor is going to the negative. And that bridge resistor is going to the positive. Okay. So there's the LDR. And then we've got another resistor going there, so that's 12K. And that was 110K, I think. Which, if that was in PNP, normally then, as that gets brighter, it lowers in resistance, and you'd want the light to go off when it got brighter, so that's wrong. That transistor is it's a 2N transistor, I can see that bit. (2N5551). I think that might be an NPN transistor. I wonder why. That means it would be like that, because it wouldn't work if it was a PNP. It would work in reverse. It would actually light up in daylight and go off at dark. I wonder why they've got a tricky. I'm not 100% sure why they've got the transistor up there. Normally the NPN transistor would be down here. That's an odd little bit of circuitry. I mean, it works, but I'm not 100% sure why they've got the LED on this side of the transistor, unless it's some... I'm not really sure, unless it's to raise it as a threshold to make this circuitry more stable, the actual light sensing circuitry, because the actual base, the emitter voltage will rise. Maybe it's... I'm not 100% sure. That's a bit weird. Very weird indeed. So which resistor did I miss out there? I see I've missed that was the 300 ohm as a sort of inrush limiter. That's an odd circuitry. I'm not 100%. I couldn't honestly 100% tell you why they've put the NPN transistor there. Certainly, if you get any ideas, just leave them in the comments down below. That's quite odd. And I'm going to check that transistor and see if it is an NPN. I think it is though, because it's the only way it would work. Yeah, very odd, strange.